Everything begins beneath the sand. Before the world's tallest building could rise, engineers first had to remove thousands of cubic meters of earth. Every meter of soil reveals hidden information. Engineers must understand exactly what lie beneath before any foundation can be designed. Even a few millimeters of error today could become meters of deviation hundreds of floors above.
Instead of resting on the surface, the tower transfers its immense weight deep into stable rock.
This steel skeleton will become the hidden backbone of every foundation pile.
Lowering such a large cage demands perfect balance. A slight impact could compromise structural alignment.
Concrete is poured from the bottom to prevent contamination and eliminate trapped air.
Hidden defects cannot be repaired later. Every foundation pile must prove its integrity before construction continues.
The piles now work together beneath a foundation that will spread enormous structural forces.
This thin concrete layer creates a perfectly clean working surface for precision construction. Keeping groundwater away from reinforced concrete is essential for long-term durability.
Critical utilities must be installed now. Once concrete is poured, these pathways become permanently inaccessible.
Before a single cubic meter of concrete is placed, every detail undergoes rigorous inspection. Thousands of cubic meters of high-performance concrete begin forming the base that will eventually support the tallest building ever constructed.
The raft foundation had to be poured continuously to prevent weak joints from forming between separate concrete placements.
Concrete generates heat as it cures. Engineers carefully control this process to prevent internal cracking. Every batch of concrete must exceed strict strength requirements before the tower can rise.
The Burj Khalifa's unique Y-shaped footprint improves both structural stability and interior space.
The reinforced concrete core will resist enormous wind forces throughout the tower's life.
Unlike conventional formwork, this system climbs upward with the building, dramatically increasing construction speed.
Each wall section is carefully consolidated to achieve maximum strength and durability. Once the concrete gains sufficient strength, the entire formwork system lifts itself to the next level.
The core alone cannot support every load. Floor beams distribute weight across the building.
Each floor combines structural strength with space reserved for future building services.
Precision leveling ensures every future floor remains perfectly aligned over hundreds of meters. As the building grows, its cranes must literally climb with it.
Construction follows a repeating vertical cycle, allowing several floors to be built simultaneously. For the first time, the world's future tallest building becomes visible above ground. Every new floor makes transporting workers and materials more complex, requiring a carefully planned vertical logistics system. Ordinary concrete pumps cannot reach these heights. Engineers developed one of the world's most powerful pumping systems for this project. Even after traveling hundreds of meters through pipelines, the concrete must retain its precise engineering properties.
The climbing formwork advances like a mechanical elevator, allowing the tower to rise floor by floor.
The tower's three wings brace one another, dramatically improving resistance to lateral forces.
As the tower grows taller, wind becomes one of the greatest construction challenges. Every heavy lift requires precise coordination between crane operators, riggers, and engineers. Several construction phases occur simultaneously, creating an efficient vertical production line. Over extreme heights, even tiny alignment errors can multiply dramatically if left unchecked. As construction climbs higher, the concrete delivery system must continuously evolve with the tower.
The tower now dominates Dubai's skyline, yet construction is only approaching its most demanding phase.
The tower narrows through a series of setbacks that help reduce wind turbulence. The construction equipment must evolve with the tower's changing profile. Working at extreme height demands specialized safety systems and constant communication.
The reinforced concrete core continues climbing toward heights once considered impossible.
Bring it up slowly, watch the clearance on the east side. Copy that, moving it now.
While the concrete structure reached its designed limit, the tower's final height depended on an entirely different material, structural steel. Each steel section had to align within millimeters before permanent connections could be completed.
The steel crown transformed an already extraordinary structure into the world's tallest building.
The curtain wall protects the tower from heat, wind, and weather, while reflecting Dubai's changing sky.
Behind every finished wall lies a vast network of engineering systems that keeps the tower operating every day.
Some elevators inside the tower travel among the fastest ever installed in a skyscraper.
After years of structural engineering, the focus shifts toward craftsmanship and precision finishing.
Ready to move down. All right, lowering the platform now.
Every structural element undergoes rigorous verification before the building can enter service. Inspection teams approve completed systems. Thousands of independent systems must function together as a single integrated building. Before welcoming occupants, every emergency system must perform exactly as designed. Years of engineering, planning, and construction culminate in a single milestone: the official handover. Standing 828 meters tall, Burj Khalifa redefined what engineers believed was possible. From deep foundations to its steel crown, every engineering decision contributed to stability, efficiency, and record-breaking height. What began as an empty patch of desert became a global symbol of engineering ambition.